Okay, we're doing the solutions to quiz 2, the practice quiz 2. The boat is crossing 149 meters wide river. Directed so it will cross the river as quickly as possible. So the boat has a speed of 5.50 meters per second in still water, and the river flows uniformly at 3.30 meters per second. Calculate the total distance the boat will travel to reach the opposite shore. So in order to cross the river as quickly as possible, you just point the boat straight across the river. Only the y component will matter. It doesn't matter how far along the riverbank you move, so you just want to cross, and the distance you need to cross is 149 meters, and the speed is 5.50, and that will be 27.1 seconds it takes. Now in that time, the boat will drift the distance in the x direction of the river velocity, which is 3.30 times the time, which is 27.1, comes out to 89.4 meters, and the total distance traveled will be the square root of the sum of the squares of the x distance and the y distance. So the x distance squared is 89.4 squared. The y distance is 149 squared. Take the square root, and we get 174 meters. Number 2. A golf ball is hit, and it takes off with an initial speed of 24.9 meters per second and an angle of 31 degrees with respect to horizontal. The golf field is flat and horizontal, neglecting air resistance. How far will the golf ball fly? Okay, so first get the x and y components. So the initial velocity is 24.9. The x component is the cosine of 31 times 24.9, which is 21.3. The y component is 24.9 times the sine of 31, which is 12.8. So now this golf ball starts from the ground and ends on the ground. Okay, and so we have that y minus y0 is equal to 0, and ay is equal to negative 9.8, and we're going to solve for delta t. So we have 1/2 ay delta t squared plus v0y delta t. v0y is 12.8, calculated here. Ay is negative 9.8. I can divide by delta t because I have a 0 on this side here. I get negative 4.9, multiplying these together, times delta t, plus 12.8, and solving for delta t, t gets 2.61 seconds. Number 3, a baseball is projected horizontally with an initial speed 23.6 meters per second from a height of 2.05 meters. At what horizontal distance will the ball hit the ground? Okay, so the initial velocity is in the x direction. v0x is 23.6, v0y is 0. And again, the time is determined by the y motion. It just follows a distance of 2.05 meters. Ay is negative 9.8 meters per second squared. Y minus y0 is negative 2.05. So we have y minus y0 is equal to 1/2 ay delta t squared. And so v0y is equal to 0, as I said. And so now I have negative 2.05 is equal to 1/2 negative 9.8 times delta t squared. Delta t squared is equal to 0.418, then delta t is equal to 0.647 seconds. Now we want to know how far it moves. Now that we know delta t, how far it moves in the x direction, x minus x0 is v0x times delta t. That's going to be 23.6, that's the initial velocity, times delta t, which is 0.647, that's 15.3 meters. Next problem, we have a car exiting the highway in a circular exit ramp. Okay, after passing point X, but before reaching point Y, the driver starts to push the brake pedal, so there's deceleration going on. Which vector best represents the direction of the car's acceleration when the car is at point Y? Okay. All right, so this drawing is not exactly at the point Y, but I'll tilt it so it's at the point Y. Okay, so we have the acceleration, the centripetal acceleration pointing towards the center of the circle. That's what we would only have if the speed was constant. But we also have that the car is braking, so the acceleration is going opposite to. There's a tangential acceleration going opposite to the direction of motion. So there's a tangential acceleration. So we have to add these together. So we get something that's going a little bit behind the, so not quite squarely headed towards the center of the circle, but a little bit behind. So for now, if I look at the point Y, okay, pointing to the center of the circle would be straight up, but it has to go a little bit behind. And so something like B would be the correct answer there. Okay. Sort of like, I should have drawn it a little bit to the side like this. Okay, now, number 5, a supersonic airplane is flying horizontally at a speed of 2,890 kilometers per hour. What is the centripetal acceleration of the airplane if it turns from north to east on a circular path of radius 54.5 kilometers? Okay, first we need to convert everything to meters and seconds. So 2,890 kilometers per hour, kilometers 1,000 meters, hours 3,600 seconds, so we get 803 meters per second. The radius is 54.5 kilometers. A kilometer is 1,000 meters, so we get 5.545 times 10 to the 4th meters. And the acceleration, centripetal acceleration, is v squared over r. That's 803 meters per second squared divided by r, which is 5.45 times 10 to the 5th meters. So we get 11.8 meters per second squared. Now, number 6 is asking how much time does the turn take? So this is going from north to east, which is 1/4 of a turn. Because the circumference is 2 pi times the radius. 2 pi times the radius, 5.45 times 10 to the 4th. That comes out to 3.42 times 10 to the 5th meters. 1/4 of the circle is going to be 1/4 of that, so that's 8.56 times 10 to the 4th. Now the time for 1/4 of a circle is 8.56 the distance times, the distance, which is 8.56 times 10 to the 4th meters divided by the speed. So 8.56 times 10 to the 4th divided by 803. That comes out to 106.6 seconds, but we're going to convert this to minutes. So 1 second is 1/60 minutes, and that comes out to 106.6 divided by 60, which is 1.78 minutes. The reason we're going in minutes is because the answers were in minutes here. Okay, next question is how much distance does the plane cover during the turn? We already calculated that. 1/4 of a circle is 8.56 times 10 to the 4th meters, or 8.56 times 10 to the 1st kilometers. Next problem. A glider is gliding along an air track at constant speed. There's no friction. Okay, what can you say about the net force on the glider? We said that v is constant, so there's no acceleration. V net is equal to 0. Okay, a box is lowered using a rope attached to it from above. The box is moving downward, but its acceleration is upward. Which of the following is the correctly drawn force diagram? Recall the length of the force on the arrows to indicate the relative magnitudes of the forces they represent. Okay, so the acceleration is upwards, so F net points upwards. So T must be bigger than W, so that the net force is upwards. Okay, so like A. Now we go to the last problem. A block of mass 5.8 kilometers is acted on by 3 forces as shown. Force F1 is 9.3 newtons, acts to the right. A force F2, which is 6.0 newtons, acts downward. And a force F3, which is 7.6 newtons, acts down and to the left with an angle here of 33 degrees. What is the magnitude of the acceleration on the block? So first we need to get the net force. So let's say this is the y direction, positive, and this is the x direction, positive. F1 is going to be 9.3 newtons because it's going directly to the right, comma 0. And F2 is going directly downwards, so it's going to be negative 6.0 in the y component, 0 in the x component. And F3, we have to get the component, so it's going in this direction with this angle being 33. So the x component will be negative 7.6, the hypotenuse is 7.6. This is the adjacent side, so 7.6 times the cosine of 33 degrees with a negative sign because it's going in the negative x direction. That comes up to negative 6.37 newtons. Now this component here, the vertical component, is negative because it's going down, and it's the opposite side to theta, so we have negative 7.6 times the sine of 33. That comes up to the negative 4.14 newtons. So the components are negative 6.37, comma negative 4.14. And now we take the sum of these three forces, add the components together. The x components come out to 2.93. Some of the y components come out to negative 10.14. Now the acceleration is the net force divided by the mass. So we take components, we divide m for each component, 2.93 divided by 5.8, negative 10.14 divided by 5.8. This comes out to 0.505 and negative 1.75. To get the magnitude of A, we take the square root of the sum of the squares. We get 0.505 squared plus negative 1.75 squared. Take the square root. That gives the magnitude of the acceleration vector 1.82 meters per second squared.